Filled out like the whole chapter.
Good again. So 8G problem solving. Let's get straight into the question and we'll show you the maths involved. So we have the rate of change of ambient temperature in a house, so the temperature in the atmosphere, once the heater is put on, is directly proportional to the temperature of the house. Okay, so what this means is if we use the capital T to represent temperature and lowercase t to represent time, what we have is the rate of change of temperature with regards to time is directly proportional to the temperature. Okay, the ambient temperature. All right, so the rate of change of temperature is directly proportional to the temperature. So directly proportional means equal with some constant multiplied by. We did that in physics. We've covered that in 11 maths in semester 1, so that's okay. All right, given the initial temperature of 16 degrees and after an hour the temperature is 21 degrees, determine the equation for the temperature of T. So it wants us to solve through for T here. So what we're going to do first is multiply both sides by 1 on T. So we'll have 1 on T, dt on dt is K. And then we're going to integrate both sides with respect to lowercase t. Alright, so over on the left-hand side, we'll have the integral of capital T with regards to capital T. So that's going to become ln modulus of capital T. And on the right-hand side, the integral of k is a constant, that will become kt. Raise e to the power of both sides.
Do we do plus c?
Plus c, yeah, sorry. Plus c. Raise e to the power of both sides. And then we have ae to the kt. So that's the basic equation. That's the form that it takes. And we've been hitting that skill a fair bit in the previous exercises. Separable differential equations, okay, separating the variables and then integrating both sides with respect to T. So we've got this temperature equation, and now we're going to use the information we're given in the second sentence to solve through. So we have T of 0 is 16, and we have T of 1 is 21. So we're going to plug both of those values in to solve for A and for K. So when I put the number, put 0 and 16, I'll do that first. So we have 16 equals A e to the power of 0. E to the power of 0 is 1, so we have A is 16. Alright, so therefore our temperature equation is 16 e to the kt. Then we'll chuck the second piece of information in, which is when time is 1, the temperature is 21. 21 here, 16 here, e to the k. We'll have k times 1. And we're trying to solve through for k. Or we can even just express it in terms of e to the k. Alright, so like a really simple way to do this is if we divide both sides by 16, we've solved for e to the k. So that means we can substitute 21 on 16 where this e to the k is. Alright, so we can express it like that. Or if you want, you can solve through for k by doing the ln of both sides. Alright, not something that we need to do. We'll keep it as e to the k like this. So we have temperature then is equal to 16 multiplied by 21 on 16 to the power of T. Now, obviously one thing to point out is you cannot multiply this 16 through. BEDMAS says exponents come before multiplication. So that term does not simplify. We need to leave that expressed as it is. Now let's use that to answer the next two parts. And do part B manually, so we can revise sort of some logarithmic operations. although both of them you can resolve on your calculator as well. So part B says, when does the temperature exceed 25 degrees? So if you graph this function, right, we have a positive value here and it's larger than 1, which means we've got growth. Okay, so it's going to look something like this. And the question is, when does it exceed 21? So here's temperature on the y-axis. We're going, when is it larger than 21? So we're trying to find the time value for which that's true. When is it larger than 25? Sorry, 25. So what we're going to do is we're going to equate the equation for the temperature, 21 over 16 parity, with the temperature of 25 degrees. We're saying, when does the temperature, this is the temperature equation, equal 25 degrees? All right, so this is an exponential equation that we're going to solve through for t, and we're going to solve it manually. So the first thing we're going to do is divide both sides by 16. And that's going to give us 25 on 16. Then we're going to perform the natural logarithm of both sides. And then we can pull that t out front here. Okay, so we have t ln 21 on 16 equals. Now, this isn't something you need to do, but again, whenever we're dealing with logarithms, I'm just going to keep highlighting the operations that we can perform in order to simplify them or to represent them in a different way. So we could express this like this. Okay, if we have ln of a on top of b, it's equal to ln of a take ln of b. Not something we need to do, just something I'm showing. Obviously, this is true because of the laws of logarithms. We're going to divide both sides by this. Remember, this is just some number, isn't it? So what we've got then, if you express it like I have, ln of 25, take ln of 16 on top of ln of 21 on 16. This one can also be separated, but we don't need to do it. Let's plug that in our calculator. So we've got ln of 25 on 16 divided by ln of 21 on 16. And I've got 1.64. So that's 1.64 hours after being turned on. So we could say 1 hour and then 0.64 times 60 minutes. You know, if you want to work out how many minutes, 38.4 minutes. So you know, 1 hour, 34 minutes after. 38.4 minutes. So. Very good. Okay, so that's part B. Now, just in terms of how you would do that on your calculator, okay, there's a number of ways. You could go into equation solver and just type that in. Okay, so equation solver in your menu. You could go to the graph mode, graph the function, and gsolve, we want to do a y-calc. We want to do an x-calc, because we want the time. Time is on the x-axis. X-calc when the y value is 25. All right, so that's one thing we could do. Excellent. Okay, and then on to part C. What is the temperature after 45 minutes? Now, there's a little bit of a trick here. You're not just plugging 45 in here because time is in hours. All right, so 45 minutes, that's 3/4 of an hour, 0.75 hours. So for part C, we're just evaluating this, okay? Or in your graph mode, g-solving the y value when x is 0.75. So evaluate that quickly. We'll get the temperature after 45 minutes. 16 times 21 on 16. So the power of 0.75. 19.61. And temperature's in degrees Celsius. Should be at 2 rounds. All right, very good. So let's get into AG.